summer at Pinellas County High School.
Well, that-
Online student registration for the session.
Some of the first
It
period.
is mentioned January 29th through February 6th.
Huh.
For specific information on the site.
Yeah, some of the first periods, I just had to
Definitely.
some of them
We're
were
going to
notes.
use the school's
Already on the
website.
first page, so I sorted it.
Since we will continue to monitor weather and, or since the faculty will continue to monitor the weather and keep you updated. Just be sure that as you depart through at the end of the day, that you're being safe getting to your next destination. Those are all of the morning announcements. Have a great Patriot Day.
Oh. I'm gonna put the bell work up in a second, so if you do finish tearing it out, you'll see the bell work. Chapter 58. Correct. Grab a book. Pages 5 through 58. Numero uno. No, boxes, the ones over there have already been. Oh yeah, when you're done tearing them out, it really doesn't matter where you put them, but that stack, I'm gonna move them all over that stack. So if you want to put them over there, helpful please. But I'm gonna move them over because right now both stacks are the same. Yep.
Do you have any folding to put in?
That is great. You see those white binder things, sort of like the bigger one, the big binder, right where your head is. Straightforward. Yeah, under that there might be some folders. Huh? All right, so that's your bell works, all pricks. This is very possibly your exit ticket. So if you, Rihanna, you were not here yesterday, correct? All right, so you missed an important piece of a change that we're doing. I'll go over it really quickly when we do the problem, but I think everybody, was anybody else not here yesterday? So you missed the lesson as well as a change to the class in general. Holy cow. Did you by any chance check the grades? Grades are on. You're all ready, huh? Good, I like it. This? Yeah, oh yeah. Remember, There's a way we learned yesterday how to figure out how many total degrees. You know 3 of the 4 angles already, so if you only have one variable, which is all you have, then you can solve the equation. So you should at least be able to write the equation. Hopefully you can then solve the equation. Have 2 pieces. I'll give you another minute and we'll get started. Yeah, there should be calculators floating around. If you don't have a calculator. You can release the ones in front of you now. Things looks good. Give another 20 seconds. 7. So I know where we're at. Let's see. I know. Oh, I got change. Two. 4. 5. Hopefully that's right. All right, so I'm going to do I did not post yesterday's video. I was reporting 5th period. One particular student said some inappropriate things. So I was going to try to edit it, but I decided I would probably just post today because we're going to go back over it. I'll go through it faster, but it'll be the same material. I may edit that other one and then still post it, but all right, so yesterday we learned about polygons and we learned a specific rule about the interior angles of all polygons. Formula. So if I said, and again, we're going to solve for x in a second, but if I just said, what is the sum of all the angles of this polygon? Should work. How would we figure that out? What was the trick? And you can tell me like the visual trick that we can do, or just formula, whichever one. So what we said, I'll do the visual part, or the visual part first. We said, well, if we took any polygon, because a polygon has to have straight sides, that was kind of an important deal. Otherwise, we couldn't do this. But if we took a polygon, actually, let's make it even better, and we divided it. It's so weird. Nope, all over. Shoot. I don't know why. Hold that thought. It's the weirdest thing. Won't let me go straight to the corners. Now, sure. Or not. There we go. Nope, still. I give up. That's why I don't draw anything. All right, forget it. We're gonna do it manually. All right, so scratch that. So if I drew a line, if I take, so here's the key if you try to do it the visual way. Like if you struggle to remember formulas and stuff, this way will always work. Well, it'll be tougher if I give you like, and I say a figure with 45 sides. That's going to be a little tough because you'd have to create your own figure. There wouldn't be a drawing of it. And then you'd try to have to draw it and that's not going to work. It'll work on the easier ones, but if you do it this way, put like a little dot on the vertex that you're going to use. you only start from this vertex. You don't start, like I don't start here and then draw another line. Because that would create more triangles, but that's not the way. And the way you can sort of know it, if you really, really struggle visually, if you, once you draw a line, and I'll do this with one with more triangles, if you just kind of color in the triangles that you're creating, so there's a triangle. And then here I created a second triangle here. Color in every triangle that you've created. Sometimes it'll just be one if you have a bunch of triangles that you're creating. If you've colored in the whole figure, you're done. I've colored in the figure with only 2 triangles, so I'm done. Just really quickly, because some kids did struggle with that piece last year. Let's say I wanted to do this one. Again, I'm going to draw in lines, so I'm going to put a dot on a vertex. Right? Every time I draw in a line and create a triangle, I can color it in just to show that I'm done with that. There's one triangle. So now I draw again from that same red dot. I'm going to draw in my next line. So I go across to the next vertex. And again, there's a triangle. So I color in every single triangle. Again, you do not have to do this. I'm just saying, if you're struggling when you're trying to get this down. So there, now I've colored in the next triangle. Now I do this one again. In, that, color in. Next triangle. I'll draw one more, it looks like. That vertex. And now I just created 2 triangles with that last line. So now I'm going to color in both of those. Here for you, because it'll be smaller figures. So I color in both of those, and now I've colored in the whole figure. I'm done. A lot of kids see these 2 angles over here without any lines drawn to them, and they want to somehow draw a line. We don't need lines in every single vertex. We start at one vertex, put a dot on it, so you know that's where you're always starting, and then draw lines out to all the other vertices. You can't draw one to that because that's the side of the figure. I mean, you could retrace it if you want. It's not going to do anything. It's not going to hurt. But you just need to draw it to the ones that are creating triangles. And then, like I said, if you're really struggling, color in a triangle after you create it, and you shouldn't be able to mess it up if you do that. Done more. So back to this one. So we've made 2 triangles. We said, okay, well, if I made 2 triangles, I know that how many degrees in the interior angles of any triangle. You add the 3 angles of a triangle up. How many degrees? Yes. How many degrees in the interior angle of any triangle? Leslie. How many degrees in the interior angle of any triangle? Magic number would be 50. That would be a right angle. That would just be because if we had, so let's say this, we had this triangle. Told you that's 90 degrees. So the whole triangle can't just be 90 because that one angle. So how many total in the triangle? 3 added together. You know, use it for one other thing too. At least one. 90, say guess. What other number you heard is what's wrong? I need to write this down if you don't, because this is like the most important thing about triangles. First thing we did. Helen, 180 degrees, write it down. So 180 degrees in every triangle. So if I made 2 triangles, that means that triangle has 180 degrees. So if I added these 3 angles up, that angle, and that angle, that would be 180 degrees. Then, well, wait a minute, I got another triangle down here. That triangle also has to be 180 degrees. So if I added those 3 angles into this 180, and they would probably all be different measures. None of them would probably be the same. So this one would be, I'd have to use like 4 tick marks to show that's different. And then 5, And then over here, 6. They could all be different, probably will all be different. That means now if I added all those angles up, I'm basically just adding that 180 plus the 180. So we said in that 4-sided figure, there's 360 total degrees. Any 4-sided figure, there's going to be 360 because you can always create 2 triangles because there's always going to be 4 angles, which means you can always draw a line across from one angle to the other angle. Doesn't matter what the shape is. So I'll just do a simple one, a square. Well, I can draw a line right across. Not a very good one, but I can draw a line right across the middle, 2 triangles. So all 4-sided figures would have 360. We went through a process and we did a bunch of different shapes. And ultimately, we got to what Isaiah said a little while ago. There's basically a formula. If we take, actually, I'm just going to have it. Maybe. Yeah. So if we take the number of sides, oh, wait, that's not one. Regular. Maybe we didn't actually write it up. I mean, we wrote it up, but I think I erased it. All right, so here's the formula. I'll just give you the formula. If we take the number of sides, so if you did not write this down yesterday, write it now. Number of sides, subtract 2. That was the key. Because again, we just had a 4-sided figure, and that made 2 triangles. And we did it with a bunch of other figures, and every time we did it, actually, we do this. Every time we did it, we were subtracting 2 from the number of sides to figure out how many triangles we could make. Oh, there it is, yeah. I did do it at the top. So we said, okay, well, if that's how many triangles we can make, this number inside the figure, I know every triangle is 180 degrees. So we would just take the number of sides, subtract 2, which gives us the number of triangles. Let me visually show where I'm at. So this up here, the number of sides, subtract 2 is how you get the number of triangles. Then we take the number of triangles times 180. And that gives us the total degree. You can write that in. So that formula equals the total degrees. Or you could say the sum of all of the angles. Also, it's the same thing. So that's your, again, exit ticket, which you don't understand what I'm saying yet, but you're going to be getting like a 1-question exit ticket every week. Hey, here. Huh? Pretty impressive. Pretty impressive considering we're going to talk about that. Again, I mean, it's what you saw is accurate. I mean, but I just think it's funny. Let's see how you did it. So there's a couple ways you can do it. You can if it's a figure that doesn't have a ton of sides, you could visually draw in all the lines and create triangles, and then just understand for every triangle you multiply it times 180 degrees. Or if you just want to memorize this formula, again, I don't love memorizing, but if you understand why the formula works, then you could also kind of recreate it if you sort of forgot pieces of it. I was just going to say, actually, yeah, grab a book out of that box, and it is 5 through 58. So now, going back to our problem, if we then know, and again, every 4-sided figure, the formula is always going to be 4 subtract 2 times 180. So that's another reason not only can we draw 2 triangles, but the formula is always 4 subtract 2 times 180. So it's always going to be 360. So really moving forward, when you see 4-sided figures, I don't really care if you show me the work on how you get the total number of degrees. If you just if you just went ahead and you just set this equal to 360, you wouldn't show me how you got to 360. Or in this one, same thing. If you just said, okay, well, I know I take Did everybody write the formula down from the other page? Number of sides, subtract 2 in parentheses and then times 180. Write it down. Go back to that. And here, I'll just write it again right here real quick. Oh. So number of sides, subtract 2 times 180. And that is the total degrees. Like the way I wrote it over here. So you're writing this up. You did not write that down. Again, pretty much telling you your exit. If that's not your exact exit ticket, you will need that for the exit ticket. There's only one other thing that I might do, and I'll show you that in a second. I'll speed up. Oh, I'm going to try to find some IXLs. So I need to clean my board and start writing the new stuff up. But I didn't do this as much first quarter. I started doing it in second quarter, but I'll add the IXLs that will work also, since I think some of you like the IXLs that give you help. A lot of times the quizzes will be more difficult than the IXLs, but the exit tickets won't. The exit tickets we do will be like pretty in line with the IXLs. So they will be good practice for those. So if you prefer to do that as opposed to book pages, now when it comes to the quizzes, the book pages are going to still be better. But for the exit tickets and for the easiest questions on the quiz, IXLs aren't bad. All right, so everybody got that up top? All right. So now let's go ahead and, so if you just, again, now that we kind of understand every four-sided figure has 360 degrees, we could just go ahead and go straight to the formula. I don't care if you show me how you get the 360. Calling somebody. I think I heard from Ben. So Ben, what's my equation that I would need in order to solve for X? And again, this is this equation will not change the process. The only thing that will change is maybe what's in each angle. Like I could have, like I had here, I could have a bunch of stuff in the angles. So instead of just a number or just a variable, I have a combination. This is still the measure of the angle. This is the measure of that angle up there. This is the measure of that angle there. That's the measure of that angle. It does not matter that we have variables in. A variable is just an unknown number. We don't know what the measure of the angle is, but that is it. Again, I'll repeat for any new students and people that weren't here as much. You can have $20 in a lot of different ways. It's still $20. Doesn't matter how it looks. Ultimately, the value of that money is $20. 2 5s and a 10 is $20. 4 5s is $20. You can have ones, quarters. You could throw in all kind of different combinations. They're all $20, but none of them look the same. It's the same thing. These are all numbers. Like, they're not the same numbers. Don't think I'm saying these are the same numbers, but don't get caught up on the fact that there's variables and different numbers. Sometimes you can have things that look totally different, but they are the same number. But don't get caught up on the way stuff looks. Just understand that is just some number ultimately. We just don't know what it is yet. That's why we want to solve for X, so we can figure out what this angle is, or this angle, or this angle, or this angle. So now, back to it. What's my equation then? Well, let's set an equation up first. You're solving it already. So do you know where I'm going with that? Like how to change what you were going to do? Well, not that piece. Let's say we know that all the angles are going to equal 360. So what would we do? Yeah, so we'd add all the angles. If we know those 4 angles have to add up to 360, and again, if you want, circle what's in every angle. If that helps you to write it down, circle all of the angles. If it's more stuff than just one variable, circle it all. Whatever is in front of that degree symbol is the measure of that angle, even if it's got variables in it. Now you just add all those things you circled together. 110 plus 115 plus 85 plus X, and then you say equals the 360. Whoopsies. So now, oh, right, 360. Now you can solve for X, and what Ben just said is the way you solve. We would take all of these, I would add them together first. Personally, you don't have to, you could subtract them one by one. You could say subtract 110 on this side, and then subtract 110 on that side. Subtract 115, and then subtract 115. I would add them all up first. What I get, 200, 310. Oh, in my other hand. While I'll do it with blue, 310 plus X equals 360. Now, how do I solve for a variable? Back to algebra. What's solving for a variable mean? What do I say? You know what I say it means? X by itself. Yeah, I want to get that X by itself. So if I want to get X by itself, I need to get rid of 310. So the way I get rid of 310 is I just subtract it. I do the opposite math. In this case, that is subtraction. I subtract 310, which means I got the number one rule of algebra is whatever you do to one side of an equation, you got to do the exact same thing to the other side. So X is 50. For that angle over here. Now, if it was 2X, I'd have to multiply that number times 2. Just remember that. We've talked about that before. When you solve for the variable, make sure you read the question and you figure out what it is they're actually asking. Sometimes they may say, what's the measure of the angle? Which in this case, the measure of the angle is X, so it isn't any different. But if it was 2X, I would have had to have said 50 times 2, and the angle would have been 100, even though X was 50. Just still be careful about that stuff. Oh, boy, I got to speed up. All right, really quickly. We said that a regular actually, did we get a regular polygon? Okay, we didn't get to that in here. Okay, really quickly, I asked more questions yesterday in first period, but we went a little faster. A regular polygon, so write this down. A regular polygon is a polygon still, but all of the sides are the same length. And all of the angles are the same measure. So again, that's the definition. That's just what a regular polygon is. That's what we called it when we had. So can you name a regular polygon for me that has its own specific name? Triangle. What kind of triangle? There is a triangle, but it's specific. Not isosceles, because 2 of them are the same, but the third one doesn't have equilateral triangle. Because remember, all 3 sides of an equilateral triangle were the same, and all 3 angles were the same. So that is a regular polygon. So an equilateral triangle is a regular polygon. Can you name another one? There's one more that has its own name. Square. Square. A square is a rectangle, by the way. I don't know if I said that in this class yesterday. It is a rectangle. It's just a rectangle where all the sides are the same length. That's why it has its own specific name, square. But it is a rectangle. So a square is a regular polygon. All the angles are 90 and all the sides are the same length. So here's the next piece. Now let's say I give you this figure and I say, now just solve for X. And I don't tell you anything about but I do tell you it's a regular polygon. What do we know then about this regular polygon? Just say a regular polygon. Actually, let me call it something. Vanessa, welcome back. So what do we know about a regular polygon? What did I just say? So what'd you say? Well, no, it can have any number of sides. A polygon, you weren't here when we did polygons yesterday. Polygons can have any number of sides. Well, they have to have at least 3 sides because otherwise you can't make a shape out of it. And they have to be straight. So a polygon, a triangle is a polygon, a rectangle, a pentagon, a hexagon, like all of those. So the number of sides doesn't matter for a polygon. For a regular polygon, this is true. What I just say, Brooklyn, what I just say? Yeah, I know, right? You're awake today. Thought maybe you had to reconnect. So again, you need to write, I told you to write it down. Did you not write it down? Did you not write it down? Write it down. You didn't just write it down, take it to Rihanna, what'd I say? Regular polygon has what? Literally written on board. Yeah. So we know for that polygon, we can use congruence marks if we really want. All of these sides are the same length, right? So remember our congruence marks, those don't go away just because we finished the first semester. And we could use angle congruence marks to show that all of the angles have the same measure. Well, what do we know then if we know all the angles have the same measure? Alyssa, I never call her Alyssa. What? Yeah, I saw you tuned out. It's like, you're like staring up there. What do we know then? If we know all the same, or all the angles have the same measure, what can we also say about all the angles? That's what I just said. We know they're the same measure because it's a regular polygon. I'm going to get rid of some of the markings. But what else can I say about all the angles? What do we know about one of the angles? What's in one of the angles? Only one thing in figure. There's an x, right? So if that angle is x, what could we say every angle is? They're all x, right? So we could say, well, if that's x degrees and I know it's a polygon, I know all of these are x degrees. Again, if there was more stuff written there, if this was 10x subtract 20, then I would write 10x subtract 20 in every single angle. I made it easier for you. Again, this could also be your exit ticket, something like this. That's why I made it easy to give you an example of a potential exit ticket for Thursday for you guys, in a class Thursday, your exit ticket. So I just write in, again, I don't necessarily need you to show this. I'm showing it right here. I'll show you in a second what you would have to show me. So I could say, okay, well, if I know one angle of a regular polygon is whatever measure it is, then I know all of the angles are that same measure. And it typically won't be a number. It'll typically be a variable because you can solve for the one angle. So what is also true about this regular polygon that we learned? What do we learn about regular polygons? What did we just do in the beginning? If I'm talking about all the angles and I want to know what's the sum of all the angles, what would I do? What's that formula we just did a minute ago? Yeah, so we could say, okay, well, wait a minute. If I know all the angles are the same, I can figure out how many total degrees are in all those angles, right? And again, just do what you know. This shows me understanding. A lot of you leave stuff blank, and I know you know something. You just don't know where to go after the first step, but you don't even write the first step down because you think, oh, well, I don't know what to do after that, so I'll just move on to the next problem. Like, write down what you know. Again, that could be the difference between you going from one letter grade up to the next letter grade is just giving me a piece of a couple of other problems that you don't fully know how to do. So I know how to solve for all the sum of all the interior angles. We just did a formula. Formula was, say again, Anthony. So number of sides subtract 2, and that gives me the number of triangles, but then what do I need to do with that? That's how many triangles. Yeah, I got to multiply that times 180 because that's how many degrees in a triangle. Again, if I drew in lines, color in that, color in that, color in that, that's 3 triangles, 4 triangles, 5 triangles, 6 triangles. Well, 8 sides subtract 2 is 6 triangles. That's what this in parentheses figures out, how many triangles. Then we take that and multiply it times 180 because every triangle has 180 degrees. So now I do that math, I get 6. Somebody do the math. 6 times 180, what is that? 6, 1080, 1080. All right, so this equals 1080. So again, what's the 1080? I just figure out. What's the 1080? Well, the sum of all the angles, perfect. Again, it doesn't have to be a regular, so make sure you understand this piece. This piece is another point where students get confused. This is for any polygon. Any polygon with 8 sides. So if it wasn't a regular one, like some of the sides were different lengths, some of the angles were different measures, this would still be true. Because if it has 8 sides, there's nothing in here about the length of the side, right? It doesn't say the length of the side has to be the same. It just says how many sides do we have. So any polygon with 8 sides would have 1080 degrees total. Here is the difference in a regular polygon. We know every angle is going to be the same. The definition of a regular polygon. So we can actually create a formula that only has one variable in it, because every angle is the same, so there's only going to be one variable. There's only one unknown. What is that angle? I'm going to create it like right through the middle. So I could just say, okay, well, all the angles added together. Make sure you do 8 angles. We've already subtracted 2. That tells us how many triangles. We're adding up all the angles. There are 8 angles. Hey. So again, now we're going back to adding up all the angles. We don't subtract 2 when we do this part for the regular polygon. So that's 1, 2, 3, 4, 5, 6, 7, 8. Because again, we're adding up all the angles, and we know all of those added up have to be 1080. Since it's second day. How do I solve that? I want you to try to solve it. Actually, all of you to try to solve it. I got 8 x's there, and I want to solve and see what 1 x would be. There's a way to just plug and play. If you want to just keep plugging stuff in the calculator, there's an algebraic way to solve it. For right now, the algebraic way is much faster. But if you need to just plug in numbers and try to figure it out, whatever you got to do. So you need to grab a book, and actually, I'll grab you a book and tear the pages out. Yeah, let me solve it. Let me solve you. All right. So page 5 through 58. Yep. And right. Raise your hand if you got it already. So I'm not going to walk around and check this. Now, again, remember, I've given you 2 problems is all so far that I say could be potential exit tickets. So you got it pretty narrowed down. It's either going to be something like this. Actually, that could be a potential in there too. It's the same concept, but I wouldn't make you solve for x if I gave you something that complex. I would just say, write the equation that would allow you to solve for x. So you'd have to figure out how many total degrees are in this entire figure, this entire polygon. How would we do that? Isaiah. Wait. I'm not Isaiah, it's Dad. I got to stay on. Yeah, that's really asking. So, how do I create an equation, or how do I? Let's say, how do I create an equation? If you don't know how to do that, I'll give you the pieces of it. So again, I have this figure down here. I want to know what's the equation that would allow you to solve for x. What do I need? Like, what's the first piece I need to know? So keep it going. So they are telling me, so you're good. They are telling me how many degrees in each angle. No, they're not telling me the number. They're using variables. but they're telling me the measure of each angle. This one is a number. So if I could set something equal to a number, because I only have one variable, right? There's only one variable in this problem, and all the angles is just x. Then I could say, well, wait a minute, if I could set that equal to some number, like if I knew the total degrees and all of the angles added together, then I could solve that. Well, that's the formula we learned. That formula right there gives us the total degrees. Or if you want to draw triangles, you can draw triangles in. You could create 3 triangles out of that. So if I multiply that out, that figure, and this is again, any 5-sided figure, because again, it doesn't matter what it looks like, because if it has 5 sides, I'm putting a 5 in it. I don't care what it looks like. Any 5-sided figure, just like any triangle has 180. I mean, you can actually just do, I think I have this in the lesson somewhere. You could actually just do this if you really want to on your paper at the beginning of the quiz. A 3-sided figure has a total of 180 degrees, right? A triangle, any triangle, 180. Any 4-sided figure, we just add 180 to that. We're just, every time we add a side, we're just adding 180 degrees because we're just adding one more number here, which means we're adding 180 one more time. So you could just create this at the beginning of a quiz. And I'm fine if you show this on your paper so that if I added 180, that's 720. Go as high as you feel like you want to go. 7 sides would be 900. Yeah, I'm fine if you just create that at the beginning of the quiz. Oh, your quiz. Shoot, I've got to tell you. We're off Monday. I didn't even know about that. So it'll be Tuesday. You didn't know we're off Monday. I don't know, some holiday. It's okay. Martin Luther King. Oh yeah, so yeah, I didn't even know that. Nobody mentioned it when I said quiz on Monday yesterday. So again, if you do that on the quiz on Tuesday, create it as far down, just keep adding 180 and then write, adding a side and adding 180. That's fine. I'm more than fine with that. Now, if we know then that this is 540 degrees, go ahead and finish the equation for me. Shandy, I called on Shandy. So what would my equation, again, we're not going to solve this. You can do this in the book if you want to solve it. What would the equation be to solve for x? You see it? Well, we want to solve for x. So we know that there is a total of 540 degrees because that polygon has 5 sides. Perfect. Circle the angles. If you need to be visual, you're good. You're good. Thank you. Circle the angle. Circle what is in every angle because that is the measure of the angle. You're struggling. I'm giving you processes and a lot of you aren't writing this stuff down. So write it down. If you're struggling, circle whatever is pointing to that angle because that is the measure of the angle. Now we just need to add up the measure of all the angles and we know it's going to equal 540 because we just solved that out above. So I just over here, I just write, okay, what are the 5 angles in that figure? Well, they're what I circle. I actually have 3x plus 14 twice. If you want to put parentheses around them or something just to kind of help you keep it straight, you don't need them. It doesn't affect the math, but if that helps you. That's your equation. So again, that could be your exit ticket, something like that. I won't make you solve for x on the exit ticket because that's more time consuming. But I would just say the only thing you would really have to solve is how many total degrees in the polygon. And then you just write all the angles added together on the other side. And again, if you want to do this instead of solving, like instead of using the formula, if you just want to write a chart, all the possible sides and how many degrees they would have, show me that, and I'm fine with that. 900. We just keep adding 180, so 900. So if you added 180 again, it'd be 1080, which is what we got a minute ago when we did an 8-sided figure. But any figure with this number of sides, doesn't matter what it looks like, will have that number of degrees in the internal angle, interior. Oh my goodness. Oh, and then again, for a regular polygon, there's a formula. I'll give you the formula. And I'm going to give you actually two formulas, and then we'll probably think you can get started on the problems. There. So write that first. So again, for a regular polygon, make sure you write that in your. This is only possible and only necessary if it's a regular polygon. So if you want to find the measure of one angle of a regular polygon, like what we just did, where I had an X, that's how you do it. I'll let you write that down, and I'll point out what I would consider to be the only thing you need to be careful on that formula. When you're done writing, here's the problem. So when you're done writing, start on the problem thing. Let's start up in 7. Oh, I don't think I'm going to. Oh, what? Oh, so you can get started on page 9. You can get started on problems 1 through 4 if you get done with that. They're going to be more, but maybe colors. So if you get done writing that down, I'm going to put another formula up in a second, but while you're waiting, you can go ahead and start on 1 through 4. I might give you a chance to work on number 1 real quick anyway. So just start on 1 through 4, and I'll give you the other formula in a minute. And then we'll do an example with the other one. There's a little one complex. A little, not one. Down to attendance. Now, when you guys are writing that down or working on the problems. And then by the time I get done with that, maybe we'll go through one problem together and then we can do the next topic. Soccer game tonight, if anybody, although it might be raining, so I'm not sure it's a great one to go to. A soccer game at home. There's also one on Thursday at home as well. If you know anybody that plays on the soccer team. I think there might be boys basketball this week. Oh, do you know if there's boys basketball? Tonight also? I like it when you're at home. I like it when you come watch you guys and you try to get outside, talk when it's not raining. So that may change. I'm not feeling great. I got 4 hours of sleep. Sneezing, which is not good. I feel maybe I'm thinking that. I think I'm gonna have to try that. Come back up. Who do you guys play? They dropped 100 on us last year. Either Lakewood did or Gill did. I don't remember what. Or maybe both of them last year. I don't know. Yeah, they're typically pretty good. What time does JV start? 6:30? And varsity is normally 7:45. Yeah, right after, but like typically your games are, although your games normally run a little bit longer, but all right, so if I came back up like 7-ish, I could see the end of you guys and then the beginning of varsity. No Jamarcus today. No Tarvis. Say don't think Camila goes. Does anybody? You guys probably don't know her. Does anybody know if Camila is trans? She said she was transferring schools. Isn't her? Yeah, she said, I think she might be transferring schools, so she may be gone permanently. Damon, I don't know where he's been. Jorvik's not here, I don't think. Andy's here. Ben. Oh, Sade. Great. Oh, yeah, she told me she was going to be gone. All right. Let's go ahead. We'll do problem one together, just so you're not, if you're struggling, so you're not sitting there and you don't understand how to do anything. Where are the problems? There we go. All right. So again, potential exit ticket question. I would not make you solve one of these on the exit ticket, but setting up the equation could be the exit ticket. The other possible exit ticket is I could give you a regular polygon and say, then I would tell you how many degrees in one angle of a regular polygon with 10 sides or something like that. So, number one, what do we have to do first? If I want to figure out what x is, and again, what are these things talking about? Like, what are all these little, they look like equations, they're really called expressions. What are they referring to or talking about in the picture? How do you know they're about the measures of angle? The easy way. There's a degree symbol. Those of you that weren't with us. Vanessa's not new, but she is. So Shandy really just. If we see a degree symbol, then that is about the measure of that angle. The easy way to know. Like if there's no degree symbol, then it's about the length of a line segment. There's no degree symbol. If we see a degree symbol, that, again, circle if you need to, that is the measure of angle Q. Pointing inside. And not only is it pointing inside, but there's the degree symbol. This is the measure of angle S. And they're not the same. Like 2x plus 5 is definitely not going to be the same number as 2 times x plus 7. This is the same as this one, but those are the measures of those angles. So I have just circled the measure of every angle. Doesn't matter what's inside that circle. That's the measure of the angle. Now, no. After this, you need to see the setup. So you don't have to stay for solving, which I will do, but you need to see the setup because this could be your exit question. It's not super challenging. What's the other thing? If I wanted to solve for x and I know all of those angles are circled, what do I need to be able to do to solve for x? What do you need? I'll let you answer in a second, but let me just ask a general question. What do you always need to solve for a variable? Like a very generic, vague word. You need a, and technically need an. Hard to get you on the same track. I need to set up a equation. You write that down. Write it down. If you're solving for a variable, you need an equation. That's the whole reason we learn to solve equations in algebra, is so that we can then in real life set up some kind of an equation for an unknown number. And now we know how to solve it because we learned how to solve it by, solving equations first. Like that's what you do in algebra. I mean, you do word problems in algebra already also, so you have to set the equation up in algebra as well. But the whole point of learning how to solve first, like learning how to solve a two-step equation or a multi-step equation, is so that when you have a real life problem where you can set up something equals something, now you know how to solve and figure it out. So we need to set up an equation to solve for x. Now, Sheen. Like, go ahead and what's the equation? We need to say, we know that every angle added together has to equal the total measure of all the angles, right? And I'm not going to go through the math and use the formula because we already said earlier, every four-sided figure is 360 degrees. Because again, if it has four sides, then we're saying 4 subtract 2, that's how many triangles, times 180, that's the total degrees. So that would be your equation. That would be all you'd have to do on the exit ticket. Now, on the quiz on Tuesday, I'd say solve for X on something like that. So, but you'd still get, again, the first step almost in every problem if there are multiple steps. The first step's worth the most points. So you guys that are leaving stuff blank, you're killing yourselves. Like I try to give you 1 or 2 pretty easy problems, and then I give you some harder problems, and sometimes you guys leave the harder ones blank. If you would just show me something that you knew on the harder problems, and then you got the easy ones right, you pass every quiz. Don't leave stuff blank. You're killing yourselves when you do that. Again, if you write something that's totally wrong down, like, but when problems get difficult, you guys need to think, okay, I don't need to know how to do this problem. I just need to know how to do the first step or 2. So think of it that way. Don't just give up during class when we're doing lessons and we get to the harder stuff. I mean, hopefully you can do all of them. Worst case scenario, if you can just get enough to understand how to set it up, that would give you quite a bit of credit. And now if you get one of the easy ones right, if that was a little simpler, then you never fail. All right, so to solve, what do we do? Who wants to tell me how to solve? Let's see. Israel. How do I solve that? What do I do? How do I solve an equation when I have variables in multiple spots like that? Yeah, combine. I'm gonna use a different word, but yeah, combine the x's or combine like terms. So first, we got to put everything together that is an x. So I have all those terms have x's. So if I have 2, and this is literally 2x just means I have 2 x's. This 2x just means I had 2 x's there. Well, I also have an x and an x there. So how many x's do I have? 6 x's. That's all of a number in front of a variable, just telling you how many of those variables you have. I got 6 of them. 4 there, 2 more there. And then the numbers I just combine. So I look at where I've got numbers. Well, I got a number there. Like, and by number, I mean like no variable with it. So there I just have a number. There I just have a number. And I think that's it, right? So 12, so 6x plus 12. Again, every step you do gets you some more points. Now you have a 2-step equation, which again, I think most of you, especially if you're good in algebra, are comfortable with 2-step equations. Solving for x, we said, means what? Nathan, I haven't called on Nathan. What did I say, or who answered that earlier? Oh, you answered that? What? Somebody answered when I said, what does solving for a variable mean? How entry? What did we say? Solving for a variable really just means I'm trying to do what? I just want to get that x by itself. So if I want to get x by itself, I need to get rid of 12 and I need to get rid of the 6. Now, if you can start with addition or subtraction, you always want to do that. Or as Ms. Thompson says, start farthest away from the variable. So 6 is right next to it. I want to start with a 12. So I'm going to subtract, because I always want to do opposite math to get rid of it. Adding 12 doesn't get rid of it. I just added 12 more to it. So I want to do the opposite math to get rid of it. Well, whatever I do on one side, I got to do on the other side. I'm kind of running out of room, but I think we can still finish it off. So now I still have the 6x. If I subtract that, I have 348. Now, how do I get rid of that 6? Yeah, if that 6 is being multiplied times x, I need to do the opposite, and that's what 6x means, 6 times x. So the opposite is divide. Oh, I'm sorry. So the opposite of 6 times x would be divided by 6. So just divide the 340. So if I divide on the left, just put there, thank you. Then I need to divide the 348 by 6, and that's your answer. Other 3, 1 through 4 are done the exact same way. I'll let you try now. If you didn't make it to number 2, if you couldn't do number 1, try to do number 2 on your own. If you made it, then just keep working. If you're completely done, we're gonna move on to the next topic in a second. Make sure you bring it back, please. Say good night. There. So I'll give you like a minute or two to at least start the second problem if you haven't already. All the x's out together. So you have a two x's here, right? So, and literally you can just count. So there's 2 x's, 3, 4, 5, 6. Combining like terms. Fine. Who's right? It was good. I went up to tell my parents, nothing crazy. I went up to tell my parents. Drove one day, was there for 4 full days, and then came back first thing.
How long does it take to get you up there?
Too long.
Yeah,
I'm not a big fan of driving.
yeah.
It ranges, if it's like, if everything goes perfectly and there's no traffic, I can get there in 5.5 hours. If it's bad, like leaving on a Sunday or something like that, when there's gonna be a ton of people on the road, especially because I go up to holidays, so what people are traveling, they can take 6.5. Maybe a little more.
How do you go up?
But it kind of depends. I've changed my methods over time. And if I go during the week, like on Tuesday, Wednesday, Thursday, I pretty much always do interstate, 75 guides in.
Yeah.
If I'm going on a weekend day, and especially if it's during holidays, I'll go like 98, like basically along the,
Gotcha.
if they live at the beach.
Like 19 up that way.
Yeah, 19 turns in 98, and then 98 just goes all the way along the coast to their house. And there are other versions of that I can sometimes do if there's some traffic. Even on those, I mean, not like those are back roads, but they're not interstate. The apps are pretty good about telling you that, there's congestion ahead or something, so you can just get off the route you're on. You don't even have to look, just get off the route that I'm on and it'll redirect me and give me the best route. I'll give you another minute to kind of wrap up number 2 or 3 or 4 or whatever you're on. 4, apparently, listen to them. Good thing I trust you. All right. So here's the more complex piece that we're getting into. And there will be another thing we'll add in on Thursday that will not be an exit ticket item. Like I've already told you what could be your exit ticket, just those 2 things. Either setting up this equation or solving for something simple in a regular polygon, meaning all the angles are the same. These next 2 things are more like quiz questions because they're a little tough. Well, this next thing and then what we do on Thursday. So there will be some problems, and again, there's an easy way to do some of these. It takes more time, but it'll get you there. If I have a problem, and I think I put them in here. Oh yeah, right here. Where I'm kind of going backwards. Like they're not telling me what the polygon is. Like they're not saying how many sides the polygon has. They're telling me that it is a regular oh crap, there's 2 things. Oh, we'll do that. I really need at least, I'll probably introduce that today and we'll finish it. They're telling me you have a regular polygon, but they're not saying how many sides. They're telling me how many degrees are in one of the angles. And then they're saying, well, if there's that many degrees in the angle, how many sides does it have? We're having to like go backwards. Normally we're solving for these numbers here. Like when we solved out, what did we get? 135. Oh, I didn't even give the answer out of the other one, did I? The answer to the other one was 135 when we solved the one that had 8 sides. So a polygon with it, and again, these numbers don't change. Anytime it is a regular polygon with 8 sides, every angle is 135. That will never change. Anytime, I mean, I'll give you a couple of easy examples. If you have a triangle and all the sides are the same length, how big is the angle? How big is each angle? What's the measure of each angle? All the sides are the same length in the triangle. Yeah, that's an equilateral triangle, right? That will never change. An equilateral triangle is a regular polygon. Every equilateral triangle, all the angles are 60. It's the same way for every regular polygon. So you really could almost memorize them. And then if they gave you one with like a ridiculously high number, you have to try to figure it out. But you could memorize them all the way up to, or I mean, not memorize them, but you're like, you can write them down, figure them out, kind of figure them out and just write them down. What would a regular polygon, any regular polygon with 4 sides? What's the measure of each angle? Yeah, because what's a regular polygon with 4 sides? It's a square, right? I didn't want to say square, but yeah, a square, right? Any square, all the angles are 90. All we're doing every single time is finding the total and dividing it by how many sides. So when we go backwards, we got to say, okay, well, wait a minute. How would I start with that measure of the angle and go backwards? So again, if we think of our formula that we just wrote, oh, there it is. So instead of solving for the angle, they're going to give me this number, and I got to somehow go back and figure out the number of sides. Well, you did this in algebra, and you probably don't remember it, but it was called, I think it was called literal equations, where you rearranged the formula. You said, okay, well, if I have this formula and it's got all variables, like, or maybe a number here and there, it's possible to just rearrange it and solve for a different variable, get that variable by itself. That's what I did. I'm just going to show you the formula. I'm not going to go through and make you try to do that. It's a little complex in this one. If we want to solve for the number of sides, that's the formula. Go ahead and write that one down. Again, memorizing isn't the best way to go because it's a lot of stuff to memorize. Although for an exit ticket, actually, this wouldn't be an exit ticket. This is harder than an exit ticket. So you'd have to, this would be something you, oh, no. So this would be a quiz. You'd have to memorize this for the quiz. This is more of a quiz. So the number of sides equals 360 divided by 180, and then subtract the measure of the one angle they get. And again, I'm not going to make you try to, there is a proof for this. Like, that's how I came up with the equation. I'm sure it's probably in the book also. Actually, it's. Oh, let's see. While you guys are writing it. I see a problem. Example 3 is the same type of problem. Doesn't have all the pages. Let me see if I can find one with all the pages. Let's see, example 3. Oh, that's the rest of it. Shoot, that doesn't have the first. Let's see if I can find the book that does. Again, if you're done, you can go back to working on the other problems real quick while I'm trying to see if they gave you this formula in the book. If they have a different one that's easier. They did not give you a formula really at all, I think. Yeah. They didn't give you a formula, they just showed you kind of how to work through it. So we're going to do that also in a second. So now that you have the, everybody's got the formula written down, right? So again, here's the reason why that works. All right, so, oh shoot, no, that's the other one. I don't have that. Fixed. So let's just go through. So if we know one of the angles is 144 degrees, right? And using the formula, we can just plug in that. So what would we, where would that go? Where does the number, I'm sorry, where does the measure of the angle that they give us go for the regular polygon? I didn't know. Yeah, so it's, well, it's 180 subtract whatever the measure is, right? So it's 180 subtract the 144 in this first problem. There's also the example in the book, example 3. And then that is underneath what? So it's 360 divided by that. And that will give you the number of sides. Simple as that. Let you do that real quick, and then I'm going to tell you what's probably going to happen and what you're going to do when that happens. Because you're not all going to remember this. You're going to get confused. You're going to not remember where these numbers go. You might remember there's a 360 and a 180 in it. You can forget where it goes. So I'm going to show you what you can do as your backup plan. I mean, the ideal thing would be to study a little bit the night before. Probably are good, but then when it comes to the EOC and you have a problem like this, you're going to probably not remember the formula. And again, key is these are all regular polygons. You guys should have that written down. Right, all the regular polygons. All right, there we go. Let me. Oh, I didn't want to. Here, I'm just going to recreate something. All right, so what'd you get? Actually, let me call him. Isaiah, wake up. These are not difficult questions, and I'm about to show you the way that you can do it when you forget, because a lot of you are not going to remember that formula, especially by the EOC time. I'm going to show you another way you can do it as your backup. What did you get, Leslie? Did you do it? What'd you get? Girl. You guys complain about not doing well, then I tell you exactly what to do. And I'm gonna. What'd you
Like the final answer.
What's final answer? How many sides? 10. Yeah, 10. And again, if it doesn't come out nice and round, like it shouldn't come out to be like 1,000 something. I mean, it should come out to be the number of sides that makes sense. Like it could still be a high number, like 40 something or even 50 something, but it's not going to be 1,000. Not anything I give you or the district gives you. Let's say now, here's your backup. Because you're going to forget this, certainly by the EOC. You can maybe study it and remember it by the quiz, you know, if you put a little time in ahead of time and remember this is the way I saw for the number of sides. But you're going to not probably remember that or study for the EOC. Any idea what you could do? Listen, what would you do if I asked you for the number of sides and you couldn't remember the formula? I give you the internal angle. Any idea what you could try to do? So, but you don't know how many sides, so how would you multiply? You're on the right track. Yeah. I mean, just guess. Like, just say, well, I know what the internal angle is, right? They're telling me what the internal angle is. I'm going to say there's even maybe a better strategy. Create a chart of all of the regular polygons. It doesn't take that long. You got a calculator. If we had a regular polygon with 3 sides, right? Which is a what? That's triangle. And if it's regular, it's what kind of triangle? So we would just say 180 is the total degrees. If it's 3 sides, then that means there's 1 triangle because we'd subtract 2, right? So that would be divided by 3. So there'd be 60 degrees in every angle. Do that for every regular polygon, all the way until you get the right answer. That'll work. Like you'll see, we'll eventually get to the 144 that they had. So if it had 4 sides, how many total degrees in it? It's a square, right? Or square, rectangle, any 4-sided, as we said, was 360. Now, though, we divide it by the total angles, which is, remember the very first day, you guys weren't here for this. The very first day, we said the total sides is the same as the total angle. So if we know it has 4 sides, then that means it has 4 angles. That's why I'm dividing by 4. So 360 is the total degrees divided by 4. And again, we know a square is a regular quadrilateral, regular 4-sided polygon. And we know a square has 90-degree angles. So that makes sense. I'm good. So this is my formula. I just keep doing that. 5. What am I doing to change this number every time? I'm just adding 180, right? Just keep adding 180. 540. What am I doing then here? What am I doing there? Oh, come on. What am I doing? I'm adding 1, right? I added 1 because I'm adding a side every time. Every time I add a side, I'm adding an angle. So what is that? 108. So these are your regular polygon angles based on the different number of sides. So if you forget the formula, just create this chart. Just figure out for every regular polygon, start with the number of sides and figure out what the angle would be until you eventually hit the one that is the problem. So I'm doing, again, let's say we forgot the formula and we're trying to get to 144. Let's keep going. So 6 sides. What's my next number? 720, right? And again, I divide that by 6. What do you get? Right, so we're still not at 144. What's the next number here? Let me say it. 900. And again, you just create this at the beginning, it'll give you a lot of answers to other stuff too. Again, this is regular, keep in mind, regular polygon. That's why I can divide by these numbers because every angle is the same. What is 900 divided by 7? 120. 120 what?
It's
Is it
well,
decimal?
it's not a whole number.
That's fine. What's the decimal?
128.5.
128. Does it keep going?
Yeah.
Yeah, I think 7 don't typically round off. So odds are they won't give you one that's 7-sided just because it doesn't come out to be a nice round measure. So again, what would 8 be? Next number. Oh, come on. Hurry. 1080, right? Divided by 8 is what was the individual measure? 130. Oh, yeah, we did this one earlier, right? 135. So again, still not at 144. Did anybody just finish 9 out? What's 9? 1,260. Is that number? Is that correct? And then what's is this a decimal? 140 even? 140, so still not at 144. And again, once you see the pattern, this shouldn't take as long. I'm waiting a little bit on you guys, but I don't think it'll take you nearly as long. Is that 1,440? Is that right? Yeah, because that makes sense, because when we divide by 10, that will give us. So now, again, it took a little longer than if you memorize the formula. But like I said, come EOC time, you're probably not going to remember that formula. But you should know how to do this. You should still remember how to say, okay, well, if I know it's regular, I know the number of sides, subtract 2 times 180 is how many total degrees. Well, then I just divide the total degrees by how many angles, which is the same as the sides, and just keep doing that until you get to the number. What's the highest number that they give you on those problems? Oh, these are your next set of problems, by the way. I forgot to tell you. So 1 through 4 on page 9. Add to that 9 through 18. Nine through 18 on page 10. And page 10, 9 through 18. So what's the highest they give you on that, not that section 9 through? Yeah, so I mean, if we kept going, it wouldn't take us that long to get to 160. You can use the formula for now. Just keep in mind, you will not have that formula, so you have to memorize that if you're going to go the formula route for the quiz. Otherwise, if you want to just keep writing that chart out and practice making the chart on your own, I don't see even the, I mean, again, you may have to go for a while, but I don't see the district giving you something crazy like it's got 30 something sides. I mean, they might, but I would doubt they're going to do that. So eventually you would get to the correct number. Might just take a little while. All right, so that's your other problems. There's one more piece I got to show you today. Almost really just telling you because I'm not going to make you prove it or anything on the quiz. So again, this is a little bit of memorization. I'll probably on Thursday, I'll go through why this works, but today, so look at page. Is it? Oh, is this the next? No. Oh, top of page 8. So they have that weird polygon. Actually, we might do this today, like the explanation. Yeah, here it is. So this is what's at the top of page 8. So what they're telling you, remember we talked about external angles of a figure. We mainly dealt with triangles. So we said, here, I'll do this. We said if I have a triangle, I'm just going to draw it real quickly. And again, doesn't have to be a specific type of triangle. We know all the internal angles add up to 180, right? But we also said, yeah, but then we have these other angles out here that are external angles. And we kind of extend the sides out, right? So I'm extending that side out to create that. And again, if I'm going this way, then my next step would be to extend that way. I don't ever extend like in both directions at an angle. I'm always just extending one way. And then I make a left turn and extend that way, and then I make a left turn and extend that way. There's going to be 3 external angles. So X degrees, Y degree, they're not going to be the same necessarily. Z degrees, don't know what they are. But we did say we know one thing about them, and it's been a while, so I'm not even going to ask. Does anybody know what they have to add up to? They do. They add up to 360. How'd you know that? It's in the book, right? Because that's what's in the book. In the book, they gave you a figure that it has like more sides. It has 6 sides. But if you'll notice, they say every polygon, the external angles add up to 360. So the measure of X plus Y plus Z equals 360. Any polygon, the external angles equal 360. Always. Always, always, always. And let's think about like a rectangle. Or actually, yeah, we'll think about a rectangle because we know all the measures of, what's the measure of every angle in a rectangle? 90, right? So what's true about every external angle then? Each individual, I should say. What's true about if this is 90, what's the one to the right of it? Yeah, because they have to add up to 180, right? Remember, that's the collinear thing. If I can draw a semicircle through 2 angles, then they have to add up to 180. So if one of them is 90, well, then the other one's 90. And the other one's 90, then the other one's 90. And what does that all add up to? So again, you can kind of work your way into what the number is. If you just think about a triangle, well, if I know that, and again, use an equilateral triangle, because if it works for one triangle, it works for every triangle. It can't work for one and not work. So if you know an equilateral triangle is 60, 60, and 60, right? I'll know that. Well, then that means every angle is 120, 120, and 120. So if the external angles of that triangle add up to 360, then the external angles of every triangle add up to 360. That's why I used a rectangle, because again, we know those are all 90. So I know they all add up to 360. So that means once I get that number a couple of times, hopefully that reminds me, oh yeah, it's always 360. But you could pick a regular pentagon, figure out how many degrees in the internal angle, and then figure the external angle out for that. Really quickly, I am going to show you how it works. We'll probably go back over this. I just want to get on the recording today too. So if I have the number of angles, right? How many angles in a triangle? Not a trick question. 3 angles in a triangle, right? What's true about all of the angles between the interior angle and the exterior angle? What's true about those 2 angles? And isn't that true everywhere, right? Couldn't I do that same thing? 180 everywhere, right? Like everybody see what I'm doing there? I mean, I'm sure some of you don't, but if you don't, again, this is you can memorize a little bit. You got to put some time into that. So I know I have 100 between the interior and exterior angles of a triangle. I have a total of what? Well, between the interior and the exterior. How many do I have here? Well, between the interior and the exterior. What's that semicircle mean?
Oh, 180.
Yeah, I got 180 everywhere. Anytime I have a semicircle, that represents 180 degrees. And that's between both. Well, then that's 180. That's 180, right? Anytime I have a semicircle, that's the total. So how many total number of degrees do I have in like all the interior and exterior for a triangle? How would I get the total number? Yeah, do that together. So what's 180 plus 180 plus 180? So that represents how many degrees in all the interior plus all the exterior. I got a 180 in each spot, right? Between the interior and exterior. Well, can't I figure out how many degrees are in the interior of any, right? Or not even have to be regular, any polygon, right? How do I figure out the interior angles of a polygon? The measure, I'm sorry, the total degrees. Oh, who's pick it up? Vanessa, back to Vanessa, even though she wasn't. How do I figure out the total, the sum of all the interior angles of any polygon? 2 ways you can do it. One was more visual, one was just a formula. Well, I don't know the measure of them. I want just the internal. Actually, here, I'm going to show you kind of what I set this up. I mean, I'm going to zoom in a minute and then we'll come back out to the end. So I'm going to color coordinate it. Actually, tell you what, I'm going to really, no, I need to be right. So again, this means 180. That means 180. That means 180, right? So I have 180 3 times. Oh, I did not want to do that. I mean, I did want to do that, but I didn't want to get rid of this number. There, that's now how I guess I can just erase it here. Trying to make it a little more visual for you. So hopefully this, I haven't taught it this way before, so you're the first. So we'll see if it helps. All right, so again, the black line represents 180 degrees, right? And hopefully we understand that. Any 2 angles that split a line, Bricklin, I'll phone. Any 2 angles that split a line. I mean, I've seen you every time you've done it. That wasn't the first time I caught you. That means part of that 180 is represented by the interior angle and part's represented by the exterior angle, right? So this is where the color coordinating comes in. So interior would be this part. Oh, it's not going to work. I'll fix it. It made it a straight line. So there, the yellow part represents how many degrees in the interior angles. And then the green part will wind up being how many in the exterior. All right, so now how many degrees in the total in the interior angles of a triangle. Better all know this. That's the 180 number, right? So if we know there's 180 in the interior angle, I'll write it in red since yellow won't show up. I know that. Well, so if the total degrees in interior and exterior is 5. I never know how to get rid of that. Oh. 540 represents the total, all the black lines, all the 180s. 180 represents the yellow. I just don't want to write it in yellow because you won't see it. So what's left over? Total. If I had a total of 540, if I take away all the interior angles, what am I left with for the exterior? Yeah, 360. 540 subtract 180 is 360. So again, I figured out how many total degrees in the interior and exterior. I took away the interior because I know how to solve for that. I got a formula, right? What's the formula? I need to, I knew it. I already knew a triangle, but I need to use the formula. What do we do? What's the formula to figure out the interior, total interior?
Sides.
That's the number of sides minus 2 thing. Or create triangles. You need to create triangles visually, create triangles. So with that in mind, how many degrees total? How many 180s first? How many 180 degree places do we have there? 4, right? We have 1, 2, 3, 4. So how many total degrees in the interior and exterior? Yeah, multiply 180 times 4. Well, how many interior? We know how many interior, just we should have memorized that by now for 4-sided figure, 20 interior. So we're going to say 360 make up the interior. So what's left over for the exterior? Also 360, right? We just subtract them. For that, if we kept going, you'd see the same results all the way down. You're always going to have, basically the reason it works is because you're always dealing with 180 everywhere you have interior and exterior. And every time you add an angle, yes, you're making this one bigger, but then you're making that one smaller. They always have to add up to 180. So ultimately, every time you do this, when you subtract it out, you're always going to have 360 left over. All right, so if you don't completely get that, like I said, you can memorize that one piece. Create a chart is another one you can just create a chart for. You could just keep going down. You see there's a pattern already, right? You can just say, wait a minute, I already see it's already 360 twice. So I pretty good guess that it's going to keep stay at 360. But if you wanted to do one more, you're just adding 180 every time, adding 180 there, which means you're staying at 360. So we'll practice mostly on Thursday, which means you'll get to practice for the exit ticket as well as for the quiz on Tuesday. And then Tuesday, I'll introduce something new in the beginning. There will probably be something new also on Thursday, but it will be on the quiz next week. It'll probably actually be something that's a full lesson. But you'll have a lot, probably at least 30 minutes. I shouldn't say a lot. But I'll try to find some IXLs and I'll tell you what the IXLs are on the. But remember, easy exit ticket question, point on Thursday. Either the measure of one angle of a regular polygon or set the equation up that would give you the total degrees of a polygon based on how many sides. And stop the recording.